Okay, Assalamualaikum warahmatullahi taala wabarakatuh. Okay, for your information, today is 1st June, and I want to show you first before we start our class. I want to show you about our RPP or planning, natural planning for chapter 6 is about numerical integration. Okay, so basically we will start the study. We will learn about the rectangular rule, trapezoidal rules, Simpson's 1/3 rules, and Simpson 3/8 rules, followed by 2-point and 3-point Gauss quadrature method. Okay, this is all for chapter 6 for the numerical integration. So without any delay, I want to start our lesson, okay, about the topic 6, numerical integration. So the learning outcome, basically we have two. Okay, at the end of the topic, at the end of this topic, you will be able to apply the numerical method in finding the integration of the given data function. And the second one is you can able to evaluate the appropriate Simpson method to be used based on the given data, as well as the others method lah, such as Gauss quadrature and also the trapezoidal. Okay, so for 6.1, it's about the understanding the integration itself. So integral of function y(x) with respect to the independent variable x within the limit x and xn. So as you can see here in figure 6.1, the relationship of integration and area of region, say they are the limit from x naught or x0 until xn. So the maximum one is the xn. So all the area below the curve is considered as the integral that we want to know. Okay, so this one, okay, this is the theory. Okay, I is integration is equal to the limits, okay, from x0 to xn, and y is the function of y, x, and dx. So represent the summation of the yx dx, the function of yx dx, over the range x0 to xn. In fact, the integration corresponds to the area region bounded by yx, xy, x is equal to x naught and x equal to xn. So this one. So basically, the close relationship between the integration and area of region particularly useful when we deal with the integration of complex. So given the function yx in figure 6.2 below, okay, this one is the integration integration area of region that we have learned, we already learned during our before entering the university, okay, the secondary school. Okay, but in here in this chapter we will use the integration based on the numerical method. Okay, in this case first, okay, the basic idea is we divided into several section. Okay, still the area under the curve, but we divided into several section. Okay, section 1, area 1 we denote as area 1, area 2, and area 3. So based on these three area, and then we identify, we calculate, okay, we get the volume, okay, the volume here, the area, okay, the area based on the area 1 plus area 2 and area 3, and then we total all the area, and then we get the value of the integration. This is the first step lah, which is okay, given the function yx, given it, simple approach is to approximate the area under the curve with some vertical segment rectangular. Okay, so we summation, we do some total of summation between the area 1, area 2, and area t. So thus we have h is this one, okay, the interval, okay, x1 minus x0 or x2 minus x1, you can get the h value. Okay, then the y is basically the y value lah, from 0 here until to y0, y1, y2 and so on. Okay, this is the basics. Okay, first based on the vertical segment. Okay, based on the rectangular. So another method is 6.2, integration using rectangular rules. Okay, this one same lah, same as before. Okay, integration using rectangular rules. So basically the point is the smaller, okay, the smaller the height, meaning that the more the section ataupun the more the rectangular you have, the better the integral result, because you will decrease, okay, this one, the area here, okay, this one, okay, because all this thing is the error, okay, that one do not consider during the calculation. So if let's say you can okay, zoom this one, then make it very small, okay, very small rectangular, meaning that the n number, the total number of the rectangular is increased. So the higher the n number, so the number of rectangular is, the better lah. Okay. So integration using rectangular rules, geometry, the rectangular rules is equivalent to approximate area. So in this case, okay, the n rectangular, n is number of the rectangles, so the higher the better. As shown in the 6.3 below, the area is divided into n division or segment where the step size h, okay, denoted as xn. So how we are going to get the h is based on the value of xn minus x0 divided by n. N is the numbers of the segment. Okay, okay, here. So okay, still same. So this is the graphical depiction of the rectangular rules. Okay, we have several rectangular. Okay, start from A1, area 1, A2, area 2, 3, 2 and 2, 3, 4 and until AN. AN the area, N is the final lah, final rectangular, final number of this one. So this is the basic idea lah. So H is based on the xn minus xo or x0 divided by n. N is the number of the rectangle. So another method is by using trapezoidal rules. Okay, trapezoidal rule is we able to minimize, okay, the error by we put here. Okay, good. Okay, yes, you can compare. Okay, this one is trapezoidal and this one is rectangular method. So rectangular method we neglect, okay, the area here. Okay, so the area here is considered the error. Okay, so by using the trapezoidal we manage to decrease the error, okay, by this one lah. Okay, now previously we put here until here, so the rest is considered error. Okay, but using trapezoidal we put here, okay, x y0 until y1. Okay, so there are two type of area actually. The first is rectangular, the second one is half, or we call it triangular. Okay, triangular. So okay, this is the graphical depiction of the trapezoidal rules, where, okay, the step size or h denoted h is same. Okay, xn minus x0 divided by n. But by using the trapezoidal rules, the theory is slightly different, whereby the h, okay, okay, we put here lah. Okay, h over 2. Okay, the step size over 2 where the y0 is the first one, y0, and then yn plus 2, the summation of uh, except the n minus 1 okay, like this one, okay. Okay, h over 2 y0 plus y1 h over 2 multiplied by y1 plus y2 and so on. Okay, it's okay. Okay, okay. This is the theorem for the trapezoidal. Okay, we will do some exercise after Simpson. Okay, so you can get a clear picture how you are going to calculate and how you can able to differentiate between those methods. Okay, the following one is the 6.4 is about integration using Simpson one-third rules. Okay, using the Simpson one-third rule actually is to improve the accuracy of estimation. A higher order polynomial can be used to connect this point. Okay, Simpson one-third rules result when a second order polynomial is utilized. Okay, again the step size theorem is same, whereby the step size is h equal xn, okay, xn minus x0 divided by n, number of segment. Okay, Simpson rules give, okay, the theory is h over 3, okay, because 3 one third, so h over 3 multiplied by the value of y0, okay, the area for the first area, the last area, plus multiplication of 4, okay, multiplied by the value of 1, 3, 1, 3 and 5, the ni lah, okay, and then this one the odd number lah, odd and even number, okay, odd and even number. The odd number is multiplied by 4 and even number multiplied by 2. Okay, so to apply the Simpson one-third rule, the number of segment must be even number. Okay. Must be even number. Okay, and for integration using Simpson 3-8 rules, okay, using Simpson 3-8 rule, actually we again, okay, the step size formula is same, whereby xn minus x0 divided by n. N is the number of segment, and Simpson 3-8 rule give, okay, a little bit length lah, okay, whereby 3 over 8 multiplied by h, the step size, and then you have to multiply the area at 0 area, and then xyn, the final, the last one, and then all the except 3, this one is the gandaan, okay, the multiplication of 3 lah, okay, 3, 6, 9, 12 and so on. Okay, all this we call it gandaan lah, gandaan 3 ni can should multiply by 2, and the rest should multiply by 3. So the most important thing during this method is actually we have to construct the table, okay, otherwise you have a possibility to misinterpret or mislead lah, okay, the number. See? So without delay, we proceed for the example 6.1, where we have some function here, okay, the approximate of the value of, okay, x over power root of x plus 1 dx ni, okay, where the limit is from 1 to 4, okay. So the x0 is 1 while xn is 4, So in order to get the H, wait, okay, H is x n over x naught divided by number of n. This one, okay, I already put here. Okay, so what is the xn? Xn is 1, xn, x0, sorry, x0 is 1 and xn is 4. So what is the n number? Okay, n number, okay, basically the n number have to identify during the question, in the question. I mean in the question, meaning that okay, this information, the n number ni, and should be in the question. Okay, should be given in the question. Otherwise, you cannot get the H number lah, the H value. Okay, so here, okay, because there are some error lah in this module. Basically, the n value should be given during in the question. Okay, so by using rectangular rules, okay, they put let number of division n equal to 12. Okay, this is very important value or very important information. Otherwise, you can get this types of number lah. Okay, so H, so H is xn minus x0 divided by n, this one lah. Okay, and so you can get the H is 0.25. So once you get this value 0.25, meaning that the step size between x to another x is 0.25. Okay, let's here you start with 1 and then you followed by 1.25, 1.5, 1.75 and until 3.75. Why until 3.75? Why not until 4? Why? Why? Okay, again, okay, the number is 12. Okay, we start here. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12 is same, is right? Same as the given value here. Okay, and I here we start from 0. Okay, same as the previous method. Okay, I the iteration is start from 0. Okay, the initial value, okay, 1, the 1 here, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Why 11? Why 12? Because okay, again kita tengok balik dekat rectangular rules. Okay, rectangular rules. Where is it? Okay, rectangular rules. Okay, here saya letak warna lain pula. Okay, can be put blue or green? Maybe green. Here this is blue, lighter blue. Okay, here okay, you focus on here, this one. So here by using rectangular rules, H, okay, multiplied by y0, meaning that the first and then the last and the first iteration, okay, 0, 1, 2, 3 until kita kata sini until n minus 1. So here the n, okay, minus 1 is 12 minus 1, meaning 11. Okay, 11 ni, this one 11. So you can see here Okay, this one is 11 because 12 minus 1 equal 11. So they start from here 0, 1, 2, 3, 4, 5. This one the I. So yang tadi tu kan y0 plus y1 is actually is yi plus yi plus 1 plus yi plus 2, something like that lah, until y 11 lah, dia punya iteration dia. Okay, I think you can get lah the point. So the most important thing during this method is, first, before you did anything, you have to apa ni? You have to clarify, okay, the value, the important value. Let's say the x 0, x and h. Okay, after this, then you construct. This is the first step. The second step is this one. Okay, you have to construct the table. Okay, you put here I for iteration. Any, I think I don't think so lah. You put here. Okay, but the most important thing is I. Okay, based on the iteration. Okay, because I ni, okay, can be here. This one is I. Okay, this one is I. Ni I n lah. I until n lah. Ni di I. Buat I. So maksudnya kat sini y0 is y I, and plus y1 is actually yi plus 1. Macam tu. Something like that. Macam tu so you have to put I and then x and the value of function of yx lah. Okay, based on this one. Okay, so x is based on this one, this number. So in this case, how you are going to get 0.8333 is you substitute lah the x value ni, okay, using this one. Okay, I think okay. So this is the rectangular method. So how about the trapezoidal? Okay, we go for the trapezoidal again. Trapezoidal also you have to put I here. Okay, the I is iteration. Start from 0 lah. Okay. So again, the n number is 12. Okay, h is 0.25. Then okay, you have to put here I. Okay, start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Okay, for rectangular, the iteration is until 11, but for the trapezoidal is until 12. Okay, because there are no such rules, okay, regarding the this one. Okay, we go to trapezoidal. Okay, this one. Okay, until yn. Okay, but using the rectangular, they put until plus y and minus 1. Okay, this one the using the rectangular. So by using trapezoidal, they until this one only. Okay. So again, we put okay, the difference is between rectangular and we put the first and last. Okay, this one the y0, and then this is yn. Okay, yn and y0 in same column, and the rest we put other column. Okay, this is the rectangular, but this is the trapezoidal, but using rectangular is same. Okay, just only one column. Okay, and only one column, where the y0 until yn minus 1 is in the same column. But using the trapezoidal, we put y0, the value of function y0 and yn here, this same column, but the rest is other column, because we have to differentiate lah. Okay, we have to multiply by 2 here. So this one, okay, multiply by 2. The rest, this one, the summation of y0 and yn is about the 2.4960. We should not multiply by others number lah. Okay. This is based on the equation here lah. Okay, multiply by 2. Okay, and then for the Simpson third rule, the difference is column. Okay, again you put I, start from 0, and then the iteration is up to 12. Yn is 12 lah, yeah, 12. And then okay, the step size is 0.25, and then this one is y0, and this one is yn. Okay, okay, the odd and even number is you have to differentiate, because they are different multiplication number lah. Okay, like this one lah. Okay, this one is this y0 plus yn. Y0 plus yn, this one, and then this is the odd number, odd number, and then even number. So all this value, the total value should multiply by this number 4, and based on this. And again for 3/8 rules, okay, again same. Okay, we should put I here. I start from 0 until 12. Okay, yn, and number is 12. Okay, this one, and I equal to 0. Okay, start from 0 to 12. Okay, so this is the y0, and this is the yn. Okay, the value of function yn, the area, yn, and then all the multiplication of 3 ni, okay, we put here. Okay, this one 3, 6 and 9. Okay, and this one is 1, 2, other the others lah, yang selain betul-betul besides y0, yn, 3, 6 and 9 we put here. Okay, in the same column here. So the total is 10.4754, and the total value of the 3 ni, the 3 is 3.9681. Okay, and this is the total value of y0 and yn, which is 2.4960. So all this value you put here. Okay, 2.5, 10 and 3, and this is the multiplication, the 3 and 2. This is based on the formula given. Okay, 3 point, this one the h, the step size h, and 3, 8. Okay, this is okay. I think enough for this. Okay, Okay, the rest. Okay, yang ni. Okay, example 6.2 is about the data set. Okay, there are two different example lah. First, the example is based on this equation. Okay, and the limit is from 1 to 4. The second example is based on the the data set lah. Okay, based on the plotting graph ni. Okay, we put start from 0 until berapa ni, 170, the y lah, the value of what speed. Okay, y. Okay. So example 6.2 is about the car velocity record from the starting point to 12 seconds as shown as follow. So again, when we go for chapter 6 ni, about the numerical integration, first you have to know about the x0, xn, the n number, and h. Okay, all these things. So how you are going to get the h? Okay, okay. X0 and xn if given lah. If cannot, then you can straight forward to get the h value. So how you're going to get the h value is based on this one. Okay, basically h, this is the step size of x. X and here is denoted as t, time. Okay, time in second. So time in second here they give you is 1 second. Okay, okay, you can, I think there are no such calculation lah here. Okay, you just can observe lah. Okay, start from 0 and then here 1 and then 2 and 2, 3, 4. So the step size is equal to 1. That's it. So straightforward you can get the h for the step size is 1. Okay, and then they ask you to calculate the distance traveled by the car within 12 seconds. 12 seconds is number n. Okay, second, using the Simpson 1/3 rules. Okay, the Simpson's 1/3 rules, the formula is h over 3, the step size over 3. Okay, multiple by the total number of the initial value. Okay, y0 plus dengan y, the last one, yn, and then plus dengan the odd n, even number lah, multiple by 4 and 2. So again, when we go for, okay, let's say rectangular method. Okay, straightforward, you can imagine the table like this one lah. There are I, there are x, and then okay, the y, x lah, macam tu. Okay, so about the trapezoidal, kita akan ada x and I. Okay, and then we have a x, and then kita ada dua kat sini okay, which is the apa, y0 and yn. Okay, y0, yn, and then the rest. Okay, how about the 1/3? 1/3, okay, 1/3 we have I, and then x, okay, then we have first and last, then odd and even. Okay, sini y0, sini y1, sini y2, y4, y6, and y3, y5, something like that. Then this one is yn, n, the last number. Okay, so you have to clarify, ataupun you have an ability to differentiate between those method based on the table. Okay, by when you want to construct the table, you may have some knowledge about the difference between the rectangular, trapezoidal, 1/3, 3/8, and so on, and Simpson method lah. Okay, so the question is asking you about how to calculate the distance traveled by the car within 12 seconds using Simpson 1/3 rule. So this one lah, okay, this table. So you have to put like this one, okay. Again, they put T. It's okay lah, T or I. Okay, T is okay lah. Start from 0, Start from 0. This is the VT. Again, there are no X, okay. They straight away put T. It's okay. T start from 0, and then this is the first, okay, and this is the last, the Y. We denote as Y0 and YN. Okay, and this is the Y1, Y3, Y5, and so on. And then this one is Y2, Y4, Y6, and seterusnya. So on. And this is the total number. Okay, 170, 640, and 545. All this thing we multiply by 4 and 2 based on the total number of different column, and then we get the final value. Okay, that's it. I think enough for numerical method by using rectangular, trapezoidal, and Simpson 1/3 and 3/8 rules. Okay, thank you class. Any question we can have during our tutorial class ataupun any discussion after this lah. Okay, thank you. I hope you able to understand about this three method. It's about the rectangular method, about the trapezoidal, Simpson 1/3 and 3/8 method. Okay, thank you.